Hello students, you have already studied the first chapter, sets, where we have defined sets, then different operations on sets. Now we are going to discuss one more operation between two sets, that is Cartesian product of sets. Before defining the Cartesian product of sets, let us see one example. Suppose you have, say, three shirts of different colors. Say, one shirt of orange color, another is a yellow color, another is a green color shirts. We have three shirts, and we have overcoats. Say, two coats of one is a white color and another is a black color. Now, the number of pairs in which we can dress up, the number of pairs here, there is one condition before making the pairs, that we have to choose shirt first and then the coat. So, if you choose the shirt first and then the coat, then the possible pairs we can make are orange shirt and white coat. Another possibility is orange coat and a black coat, then yellow shirt, white coat, yellow shirt, black coat, or we can also wear green shirt with white coat or green shirt with a black coat. These are the possible pairs of dresses that we can make from these two sets. But there is a condition that we have to select the shirt first and then the coat. That is the cross product of these two sets, S cross C. We call it as S cross C. S cross C is the collection of all these ordered pairs. So it is a collection, well-defined collection of elements is also called as set. So S cross C is equal to collection of these ordered pairs. Now here we can observe that all the ordered pairs have the first element from the set S and they have the second element from the set C. So also we can observe here that there are three elements in the set S, that is number of elements in set S is equal to 3 and number of elements in the set C, that is n of C, is equal to 2, and in S cross C we can observe that there are 6 elements, 1, 2, 3, 4, 5, 6. That is actually the number of elements in set S, number of elements in set S into number of elements in set C. Therefore, if a set S or first set has m elements and the second set has n elements, then the cross product of these two sets has m into n elements. That is the product of number of elements in these two sets. Therefore, let us see the definition of Cartesian product of sets. Given two non-empty sets P and Q, the Cartesian product P cross Q is the set of all ordered pairs of elements from P and Q. Set of all ordered pairs of elements from P and Q, where P and Q must be non-empty sets. That is very important. Suppose there are no elements in the set S, we don't have any shirt, then we cannot have the ordered pairs like this. Here order is important. The order is that the first element must be taken from the first set and the second element must be taken from the second set. So if one of the set is empty set, then there will not be any element in the cross product also. Therefore, given two sets P and Q must be non-empty. Then the cross product P cross Q can be defined as P cross Q is equal to set of all P comma Q, where P belongs to the first set and Q belongs to the second set, where P and Q are non-empty sets. Suppose P is empty set, then there will not be any element in P cross Q also. If either P or Q is a null set, then P cross Q will also be empty set because there will not be any element in the cross product also. We can see some of the examples here. Suppose set A has the elements 1, 2, 3. Set B has the elements A, B, C. Then A cross B will have the elements 1, A, 1, B, 1, C. Then 2, A, 2, B, 2, C, 3, A, 3, B, 3, C. Suppose we represent the elements of the first set on a horizontal line and elements of the second set on a vertical line. Then we can see the suppose the elements of the first set are on the horizontal line, say 1, 2, 3. And elements of the second set are on the vertical line, say A, B and C. Then their cross product is the point of intersection of the vertical line through this 1, 2 and 3 and the horizontal line through this A, B and C. The point of intersection of these vertical lines and horizontal lines gives you the elements of the cross product that we can see in the next example here. Suppose the elements of set P are 1, 2, 3, elements of Q are 4, 5. Then P cross Q is equal to the collection of all ordered pairs 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. If we take those elements of the set P on x-axis and elements of set Q on y-axis, then we can see the elements of P cross Q on the graph. Here we have 1, 2, 3 are the elements of set P and here 4 and 5 are the elements of set Q. Then A, B, C, D, E, F are the elements of P cross Q, which are the points of intersection of vertical lines and the horizontal line here. So that is the geometrical interpretation of cross product of two sets. Next we have some of the observations here. First remark is that two ordered pairs are equal if and only if the corresponding first elements and are equal and the second elements are also equal. Two ordered pairs are equal means the corresponding first element and second element must be equal. That is A, B is equal to x, y if and only A is equal to x and B is equal to y. Here x coordinate must be equal to x coordinate and second element must be equal to second element. B is equal to y. For example, one can ask the question like this: if x minus 1, y plus 2 is equal to 0, minus 3, then find x and y. We have to find the value of x and y here. Suppose this is the ordered pairs which are equal to one another, then we can see that x minus 1 value must be equal to 0 and also y plus 2 must be equal to minus 3. Here x minus 1 equal to 0 means that x value is equal to 1 and here y value is equal to minus 3 minus 2, that is minus 5. Therefore x value is equal to 1, y value is equal to minus 5 when these ordered pairs are equal. This is what the remark 1 says. Then remark number 2. If there are P elements in A and Q elements in B, then there will be P into Q elements in A cross B. We can see the example. Suppose the elements of set A is equal to say 1, 2. Elements of set B is equal to say 5. Only one element in set B. Then A cross B is equal to collection of all ordered pairs where first element must be taken from the first set and second element must be taken from the second set. That is 1, 5. Then 2, 5. We can observe here number of elements in the cross product Cartesian product of A and B, A cross B, is equal to number of elements in set A into number of elements in set B, which is equal to 2 into 1 is equal to 2. That is remark number 2 says, if the set A has a P elements and set B has a Q element, then there will be PQ elements in A cross B. Also, A cross B will have 2 to the power Q PQ subsets. Here we have A cross B which has 2 elements. Then what are the subsets of A cross B? The set collection of all subsets of a set is called power set. So the power set of A cross B will have 2 to the power PQ elements. That is, what are the elements of subsets of A cross B? That is, elements of power set of A cross B. Power set of A cross B will have the empty set, then single element set containing the ordered pair 1, 5, then single element set containing the ordered pair 2, 5, and it is the set containing both the elements, that is A cross B itself. So these are the possible subsets of A cross B. One is empty set, another is a single element set containing 1, 5, single element set containing 2, 5, and set containing 1, 5 and 2, 5. Therefore, number of elements in this power set is 2 to the power P into Q. That is 2 to the power 2. P is the number of elements in the first set into Q is the number of elements in the second set. That is 1. So we get 4 elements in the power set. That is, A cross B will have 2 to the power P into Q, 2 to the power 2. That is 4 subsets. Next note, if A and B are non-empty sets and either A or B is an infinite set, then so is A cross B. If there are infinitely many elements in set A or in set B, then A cross B will also have infinitely many elements. For example, let us take set A is equal to the set containing say 1, 2, and set B. The second set is the same set of natural numbers n is equal to 1, 2, and so on. It is an infinite set containing infinitely many elements. Then A cross n is equal to 1, 1, then 1, 2, and so on. This A cross n will have infinitely many elements. If one of the two given sets is an infinite set, then A cross B is also an infinite set. Then note number 4, A cross A means we can have the Cartesian product of more than 2 sets also. We can have the Cartesian product of 3 sets, 4 sets, 5 sets, and so on. If we find the Cartesian product of 3 sets and all the 3 sets are same, set A cross set A is equal to set of all elements A, B, C, where A, B, C, all the elements belongs to set A. Here A, B, C is called ordered triplet, and this type of points can be marked along 3-dimensional space. For example, let set P as the elements 1, 2. Then what is P cross P? P cross P is equal to the set of all ordered triplets given by, if we want we can write this is 1, 2, set P is again set containing 1, 2, this is also set containing 1, 2. Then the ordered triplets are 1, 1, then 1, 2, then 1, 2, 1, then 1, 2, 2, then 2, 1, 1, then 2, 1, 2, then 2, 1, then 2 comma 2 comma 2. These are the elements of P cross P, where P is the set containing two elements 1 comma 2. So this is the Cartesian product of three sets P, P and P. Cartesian product of P cross P, P and P. All the three sets are equal, or they may be distinct sets also. Then also we can find their Cartesian product. Next, if R is the set of all real numbers, then R cross R represents set of all x comma y, where x and y belongs to R, set of real numbers, represents coordinates of all the points in two-dimensional space. Means R cross R represents the plane, because on x-axis we can mark each and every real number on the horizontal line called as x-axis. We can mark each and every element of the second set on y-axis. So this also represents real line. This also represents real line. And if you choose all the elements on the first set R and all the elements on the second set R, and if you draw the vertical lines and horizontal lines, then the point of intersection of these vertical and horizontal lines gives you the complete two-dimensional plane. Therefore, R cross R is equal to set of all points x comma y, where x and y are real numbers, represents two-dimensional plane. Similarly, we can think of three-dimensional space as R cross R cross R. R cross R cross R is equal to set of all x comma y comma z, where x, y, z are real numbers, represents the coordinates of all the points in three-dimensional space. Now let us see some of the examples from NCERT textbook. This is example number 3 in NCERT textbook, where set A is equal to 1 comma 2 comma 3, set B is equal to 3 comma 4, then C is equal to 4 comma 5 comma 6. Find A cross B intersection C, and A cross B intersection A cross C, A cross B union C, and A cross B union A cross C. Here, the given sets are A is equal to 1 comma 2 comma 3, B is equal to 3 comma 4, and set C is equal to 4 comma 5 comma 6. Now, first we have to find A cross B intersection C, for which first we have to find B intersection C. We have already studied intersection of two sets in the last chapter. So B intersection C gives the set of all elements present in set B as well as in set C. So B intersection C is the common elements in set B and set C. That is 3 is not common, 4 is the common element among set B and set C. Then A cross B intersection C. A cross B intersection C is the Cartesian product of set A and set B intersection C. Set A is here, B intersection C is here. So cross Cartesian product A cross B intersection C is equal to 1 comma 4, then 2 comma 4, and 3 comma 4. This is A cross B intersection C. In the next second problem, this is the first one. In the second problem, cross B intersection A cross C. A cross B is equal to A cross B. The Cartesian product of set A and set B is 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, then 3 comma 3, 3 comma 4. This is A cross B. Then A cross C is equal to A cross C is equal to A has 3 elements, C has 3 elements, and therefore there will be 9 elements. 1 comma 4, then 1 comma 5, 1 comma 6, 2 comma 4, 2 comma 5, 3,6, then 3,4, 3,5, 3,6. This is the A cross C. Next, if we find A cross B intersection A cross C, it contains the common elements belonging to set A cross B and set A cross C. The common elements here 1,3, no, 1,4 is the common element among those two sets, 1,4 here. So this is one element here, 1,4. Then 2,3 we don't have here. Then 2,4 is the common element among these two. So 2,4. Then we have 3,3 which is not there in the set A cross C. Then 3,4, 3,4, 3,4, 3,4 the common element 3,4. So this is the A cross B intersection A cross C. And now we can observe that A cross B intersection C is equal to A cross B intersection A cross C. So this is equal to A cross B intersection C. A cross B intersection C is equal to A cross B intersection A cross C. The Cartesian product is distributed over the union of two sets. That is question number 3. You have to find A cross B union C. B union C is equal to set of all elements belonging to set B or set C. That is B union C is equal to 3, 4, 5, 6. Then A cross B union C is equal to the Cartesian product of set A with the B union C. That is 1,3. Then 1,4, then 1,5, 1,6, then 2,3, then 2,4, 2,5, 2,6, 3,3, 3,4, 3,5, 3,6. These are the elements of the set A cross B union C. Next we can also find A cross B union A cross C. That is distributive law. A cross B is equal to the set of all elements 1,3, then 1,4, then 2,3, 2,4, 3,3, then 3,4. Now if we find the union of these two sets, A cross B and A cross C, we have to find A cross C here. If A cross C is equal to 1,4, 1,5, 1,6, 2,4, 2,5, 2,6, then 3,4, 3,5, 3,6. These are the elements of A cross C. Now A cross C union A cross B. A cross B union A cross C gives the elements 1,3, which is also present here in A cross B union C. Then here 1,4 is also the element in A cross B union C. Then 1,5 is also in the union. Then 1,6 is also belong to the union. Then 2,3 is there, also belong to the union of those two sets. Then 2,4 also belongs to the union, is a common element. And then 2,5 is also belong to the union. 2 comma 6, 2 comma 6 also belong to the union of those two sets. Then 3 comma 3 also belongs to the union. Then 3 comma 4 belongs to the union, and 3 comma 5 belongs to the union. 3 comma 6 also belongs to the union. Therefore, if you find the union of these two sets, A cross B union A cross C, it is equal to A cross B union C. Therefore, the Cartesian product is distributive over the union of sets. That is, A cross B union C is equal to A cross B union A cross C. That property can be verified using this problem. Next exercise problems from the exercise 2.1. First question we have, if the ordered pairs are equal, that is ordered pair x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3. Then find the values of x and y. We have already discussed about equality of the ordered pairs. Ordered pairs are equal means the corresponding first elements are equal and the second elements are also equal. This implies x by 3 plus 1 is equal to 5 by 3 and y minus 2 by 3 is equal to 1 by 3. That is, x by 3 is equal to 5 by 3 minus 1, or this is equal to 3 LCM here, 5 minus 3, that is equal to 2 by 3, or x is equal to 2, or 3 gets divided, and also y is equal to 1 by 3. From here, y is equal to 1 by 3 plus 2 by 3. Where 3 is LCM, we get 3 by 3. So value of y is equal to 1. Value of x is equal to here 2 by 3 and value of y is equal to 1. Next, second question is to find A cross A when the set A is given minus 1 comma 1. Here given that set A is equal to minus 1 comma 1, then A cross A is equal to set of all ordered pairs x comma y comma z, where x belongs to A, y belongs to A and z also belongs to the same set A. That is set of all ordered triplets. That is, if you want, we can write the elements of set A, that is minus 1 comma 1, then elements of set A here is the minus 1 comma 1, then elements of set A here is the minus 1 comma 1, then the elements of A cross A, minus 1 comma minus 1 comma minus 1, minus 1 comma minus 1 comma minus 1, then minus 1 comma minus 1 comma 1, then minus 1 comma 1 comma minus 1, minus 1 comma 1 comma minus 1, then minus 1 comma 1 comma 1, then 1 comma minus 1 comma minus 1, then 1 comma minus 1 comma 1, then 1 comma 1 comma minus 1, then 1 comma 1 comma 1. These are the elements of A cross A, ordered triplets. Next problem is question number 6 in the exercise. If A cross B is given, we have to find the set A and set B. Whenever the cross product of Cartesian product of set A and set B are given, all the first elements belongs to the first set and all the second elements belongs to the second set. So using that concept, we can write the set A and set B. The given cross product of set A and set B, A cross B is equal to A comma x, A comma y, B comma x, B comma y are the elements of the Cartesian product of set A and set B. This implies that set A is the collection of all first elements in these ordered pairs. Here the first element is A, here also the first element is A. So when the elements are repeated, we write it only once while writing the set. So first element is A, here the first element is B. Therefore elements of set A are A comma B. Then set B is the collection of all second elements among these ordered pairs. That is, the second element here is X, here it is Y, here again X is repeated and here Y is repeated. So set A is equal to A comma B and set B is equal to X comma Y. Set A has 2 elements, set B has 2 elements, therefore A cross B has 2 into 2, 4 elements here. And this is question number 7, similar to the problem that we have worked now. A is given 1 comma 2, set B is equal to 1 comma 2 comma 3 comma 4, C is equal to 5, 6, A is equal to 5, 6, 7, 8. Verify that A cross B intersection C is equal to A cross B intersection A cross C. That is what we have verified now in one of the example problem. Also verify that A cross C is a subset of B cross D. One set is the subset of another set if all the elements in the first set are also the elements of second set. If you find A cross C, then all the elements of A cross C must be present in set B cross set D. Here we can find A cross C is the Cartesian product of set A and set C. Set A is equal to 1 comma 2 and set C is equal to 5 comma 6. And if we find A cross C, it is 1 comma 5, 1 comma 6, then 2 comma 5, 2 comma 6. These are the elements of set A cross set B. Then B cross D. B cross D is equal to 1 comma 5, then 1 comma 6, 1 comma 7, 1 comma 8, then 2 comma 5, 2 comma 6, 2 comma 7, 2 comma 8, then 3 comma 5, 3 comma 6, 3 comma 7, 3 comma 8, then 4 comma 5, 4 comma 6, 4 comma 7, 4 comma 8. These are the elements of B, set B cross set D. Then we can observe all the elements in A cross C, say 1 comma 5 is an element in B cross D. Then 1 comma 6 is also an element in B cross D. 2 comma 5 is also an element in B cross D, and 2 comma 6 is also an element in B cross D. Therefore, we can conclude that all the elements of A cross C are also the elements of B cross D. Therefore, set A cross C is a subset of set B cross set D. That is what we can observe here. Next, question number 9. The Cartesian product of A cross A. The Cartesian product A cross A has 9 elements, among which are found -1, 0 and 0, 1. Find the set A and the remaining elements of A cross A. Now, in this problem, given data is that number of elements in A cross A is equal to 9. Since these two are identical sets, this 9 is equal to 3 into 3. Means the number of elements in set A is equal to 3. That implies number of elements in set A is equal to 3. Now, -1, 0 belongs to A cross A, is an element of A cross A. Implies -1 is an element of set A, 0 is also an element of set A. This implies that -1 belongs to A, also 0 belongs to A by the definition of the Cartesian product of two sets. Also they have given that 0, 1 belongs to A cross A. 0, 1 is also an element. This implies that 0 is an element of set A, 1 is also an element of set A. Already we have concluded that set A has 3 elements, and those elements are -1, 0 and 1. These are the 3 elements of set A. So this is the last problem in that exercise 2.1. So that completes the concept of Cartesian product of two sets. I request all the students to go through the example problems and exercise problems, and also you try to solve all the problems with the help of your teachers. With this, let us conclude this session. Thank you.